first though. Okay, now we're recording for anybody who can't be here. And I think this is the place where we'll see. Okay, and if you have questions, you can either remember turn on your microphone and ask, or you can type it in the chat. Either way is fine. Let me open up the chat so I can see that. Okay, do you guys mind if we just start with the naming acids part? I don't remember which one actually came first in the notes, but thought we could start here. So, I don't know if I really have to do this or not, just so that you guys can hear me. But that's what I did last week, so I guess I'll do it now. Okay, good enough. So, to write the formula of acids, it's very, very similar to the ionic compounds that we did last week, where we have to look at their charges and figure it out. But what's difficult is the way that they're named. It's a lot harder to figure out what are the ions that are being added together, okay? So this table at the top is just supposed to help you. The anion ending, remember the anion is the negative ion. So that's the thing that is second in the compound. And so when we're talking about the ending, sometimes they end with IDE, sometimes they end with ITE, and sometimes they end with ATE. So we have to be careful. What is the actual name of that second part of the compound in order to name it correctly? Now, where the lines are, that's like the blank where you put in the root of the name. So like, for example, if we're talking about anything with chlorine in it, whether it's chloride, chlorite, or chlorate, the chlor, the CHLOR, is the base. And so that chlor is what we fill in for those blanks for the names. Okay, so like looking at number 1, we have HC2H3O2. And just FYI, I did start grading the ionic compounds worksheets that were turned in last week, where we were supposed to be. And I've noticed that some people may be either looking at the answers or checking their answers online. Unfortunately, though, it doesn't, like Google, does not tell you a way what it should be in the grouping that I need you to know it. Because, like for this, for example, we need to know what the C2H3O2 is called in order to name it properly. And if it's not written in this exact way, it's hard for you to tell that C2H3O2. So it's hard to look that up, okay? Something I forgot to pull up. We need, let's go to this page. I forgot about the polyatomic ion list. Oh, sorry. Let me get that really fast. Okay, so can you guys see the polyatomic ions now? Just want to make sure I'm sharing the right thing. Hopefully. Okay, so we are looking for the C2H3O2, which is number 1, acetate. Okay, so that acetate is the name of, I don't know if I can write over here, let's see. No, I can't. So acetate is the name of the C2H3O2. Okay, and this is where that anion ending, the second thing, what's the name of it, comes into play. Since we have okay, safe. So since we have the ATE ending, oh, there we go. we are going to take off the ATE ending and add the IC from this part right here. Okay, so the name of HC2H3O2 is going to be ACETIC, that's pronounced acetic, and then every acid has the name acid as part of the name. So it's acetic, and then separately as another word, acid. So the correct name of HC2H3O2 is acetic acid. Okay, now let's try one, like another one. So like let's just skip over to number 5. Okay, let me erase a couple things. Wait, no. Oh, I don't know. Anyway. Okay, so then for the HBr, the H in the front, a way that I always tell students is that H in the front is just telling us that the second name, or the second part of the name, is going to be acid. It has no other effect on the name other than letting us know it is an acid, okay? What's important is what comes after the H, which in this case is Br. So Br, if we try to look at the polyatomic ion list, you won't find Br anywhere on there. There's no Br. So that means that instead of being from this list, that means it's from the periodic table. And when it's from the periodic table, that's when we would call it bromide. Remember, if it comes second and it's negative, we change it to IDE ending. Some people forgot to do that on the worksheet that I started grading too. So since it's the IDE ending, since it is the IDE, then this time, that means we're going to follow the top line, where we put hydro in front of the root, which the brom is going to be our root, okay? So our answer is going to be hydrobromic. That's really scrunched, sorry. Hydrobromic acid for HBr. Again, what makes people really confused is you only put the hydro in front if it's from the IDE ending part. All the rest of them don't get hydro. And so there's actually 2 ic endings, but the ATE ending, like we had for number 1, does not get the hydro in front. Okay, so let's do one more. Let's do number 8. Okay, so number 8, the important part is the NO2. So we're going to need to know the name of the NO2. The H in front just tells us that the second word will be acid. Okay, so NO2 is a lot of different elements. There's nitrogen and oxygen. Since there's more than one type of element, that tells me it's on the polyatomic ion list. Okay, and so NO2 is number 13, nitrite. NO2 minus 1 is nitrite. So that means that we're looking at the word nitrite. Okay, the root of the word, let's go with blue. I'm just picking colors. Now that I figured out how to change the color. So our root of the word is going to be the NITR, but then we're going to change the ending. So we're going to get rid of the ITE, and this is where we're going to follow the second line, the OUS. So we replace the ITE with the OUS ending. So it's going to be called nitrous acid. Nitrous acid, like that for HNO2. So how do we feel about that so far? You do have to do all 15 on this page, or whatever, however many there are on this page, but like I've already done 3 of the top with you, so hopefully you can do the bottom. Don't understand how to do number 2? Okay, so number 2, we're looking at what is ClO2 called. And so again, since it has Cl and O, we have to look at when there's more than one element, that means it's probably going to be on here. Okay, and ClO2 is number 5 in fluorite. So the name of the ClO2 ion is called chlorite. And so this one, number 2, is going to be like number 8. Since it ends in the ITE, so the ITE is like the nitrite, chloride, and nitrite. So we're going to get rid of the ITE part and add the OUS like we did on number 8. So the correct answer for number 2 is going to be chlor, OUS, chlorous acid. Okay, so it all kind of goes back to what is the name of the thing that's with the H? And that's why I said, like, you need to either print this off to have with you or write it down somewhere so that you have this with you so that you get the hang of these. Until we use them a lot, which we're going to use these a lot this year, you will start to recognize them after a while, but right now you don't because we just learned about them. So make sure that we have those there, okay? So that's how we do the naming. Okay. There's a way to just erase the lines. So yeah, good question. If for Levi just said, what does it mean if the H has a number in front of it? Then what do we do? So like numbers 6 and 7, how it has H3PO4 or 7 has H2SO4. For the name, that's not important. But the reason why the 3 and the 2 are there is because of making the charges equal 0. Okay, so that comes into play with the formula writing at the bottom for the second part. Okay, there's 16. All right, so that's a good question. Like, let's do one first that doesn't have one of those numbers, and then we'll try one that does. Okay, so like number 11, nitric acid. Okay, so we kind of saw up in the naming part, every acid starts with an H. Okay, so this is following the same thing that we did last week, where we have to look up everybody's charges and make sure that charges add to 0. So everything is going to start out with an H+1 as its cation, and then the name will tell us what that anion is. Okay, so for number 11, we're dealing with nitric acid. So this is where we have to look at that table, and that's why I included it for us. Okay, but with the ick and no IC in front, that means that we're going to deal with the bottom row, the ATE row. Okay, and that's all because of the ick part, right? Yeah, the ick part of the nitric acid. Okay, so what that means is we have to look up what is not nitric, what is nitrate. And since it has the ATE ending, then that means that it's going to be on this list. Okay, and nitrate is number 12, NO3 minus 1. So we're going to combine the NO3 minus 1 with the H plus down here. Okay, now remember from learning how to do these with the charges, we look at, do these two, I'm going to turn black. do they add up to zero? So we have a +1, we have a -1. Yes, they do add up to 0. So the answer for number 11, nitric acid, will be HNO3, like that. So this is a case where we don't have more than one H. Number 4 is just chlorine. Yes, it is, Zach. Number 4 is chlorine. But 11, so it's HNO3 because there's 1 and 1, like that. Now let's try one, Levi, like what you were asking about, where there's more than one H. So like, let's do number 15. Okay, so we have sulfurous acid. So we know it's going to combine with H+1 first. Okay, but then looking at the OUS from sulfurous follows along with the middle line, the OUS, the ITE. So the OUS here is talking about the middle line. So instead of dealing with sulfur or sulfide or sulfate, we're looking for sulfite. I just spelled that wrong. Oops. Sulfite. So we're looking for the sulfite ion, and the ITE tells me it's going to be on this list, and that is number 21, SO3 -2. So we're going to combine the SO3 -2, the sulfite, with our hydrogen ion this time. So this time, with the SO3 -2, the charges do not add to 0, as if there's +1 and a -2. Okay, they don't add up nicely to 0. So when they don't add up nicely to 0, you have to increase a certain number of the ions to get it there. Okay, so we don't have enough positive charge to balance out the negative charge, so we're going to need another H+ in order to get an overall +2 with the -2 to make it work out. So the final answer for this one is going to be H2SO3 for sulfurous acid. Now, can I tell you like a super duper hint? And this is something that, like, if we would have been in class like normal, I would have taught this a lot faster. But so I try to teach a little bit about those Roman numerals. But a trick way to know how many H's you will need is it matches. So if you look here, we're combining those two ions to make sulfurous acid. Okay. Whatever the charge is on the anion, on the second part, the negative part, that number is going to become the subscript on the H. So, like, since it's a -2, that's why we have 2 for the H2SO3. Okay? That also applies for, like, the nitric acid, number 11. Since it was a -1, there's only one H. Okay? So, like, if you had a -3, then that means you would have 3 H's. Does that make sense? Okay. And 14. Okay, well, let's pick 9. So, we all know that it's all going to start with an H. It's an acid, okay? Now, this is where we need to look at the table and figure out what does hydroiodic actually mean, okay? The only one that has hydro in front is the top line, the hydroic acid. So if we take off the hydro and we take off the ic and we add what it says is the anion ending, so instead of hydroiodic, we're going to take off the hydro and ic, and it's going to be iodide. Iodide. Okay? And iodide with the IGE ending, you could look on this paper, but there is no iodide on this paper. So that means that the iodide is really iodine from the periodic table. So we need to look up on the periodic table, what is the charge on the iodine? And I don't know that. Hold on. So on the periodic table, iodine is in 7A, which I don't have written on this one, but 7A means that it will have a -1 charge. You should have that written down on yours. So the hydroiodic acid, we're taking the H plus with the I -1. So the answer is just going to be HI because it's a +1 -1 charge. So I have a question. Are you guys having a hard time figuring out from like the table at the top what to do? Are you having a hard time, like you can figure out what it is, but you're not combining them correctly to write the right formula? Or do we think we're okay now? Okay, thanks, Levi. Because tomorrow, after today, tomorrow, I'm gonna just like throw them all together at you. So we need to know how to do this. Okay, yeah, Zach, I completely forgot there's another page. There's another side. So at this time, I'm gonna stop talking about the naming acids paper. If we need to come back to it later, I can help you. But let's talk about the molecular compounds. Okay, this is something completely different, and this one's actually a lot easier than ionic compounds or acids. It's a lot easier to do, and you guys are gonna like be so mad at yourselves when you realize how easy it is. Okay, so molecular compounds are the only things that have these prefixes, and the prefixes tell how many. So the reason why I put this at the top on the paper is so that you know, like the prefix for 1 is mono, and the prefix for 2 is di, and 3 is tri, and 4 is tetra, 5 is penta. These are from the notes. 6 is hepta. No, that's not right. It's hexa. Oops, kidding. I got 6 and 7 mixed up. So 6 is hexa, like a hexagon, and then 7 is hepta. 8 is octa, like an octopus. 9 is nona, and 10 is deca, like a decade. Oh my goodness. Okay. Hepta, octa, nona, and deca. Okay, so this one, these prefixes, they tell how many atoms are there. Okay, Britt, I will go back to the naming acids after I talked about this paper, okay? So now with the molecular compounds, there's no charges involved. No, like it's really straightforward, okay? So, like for example, to name them, okay, for number 1, we have C3H7. So the subscript, the little number on that element tells you what the prefix will be of that element, okay? So if it's 3 carbon, we're gonna say tri-carbon. And then the second one, you have to put the IGE ending, just like we did previously, but we don't do that on the first one, just on the second one. So tricarbon, and then 7 H's will be heptahydrogen, but it's going to be heptahydride. Heptahydride. So tricarbon heptahydride is number 1. Okay. Now, also, you only use mono, only used on the second part. So like for number 7, we have SEF2. There's only one SE, and that's called selenium. SE is selenium, but we're not going to put monoselenium. We're just going to put selenium because it's the first part. So selenium, I think there's 2 L's in selenium. That's hard to read. Is there only 1 L? Oops, sorry. Okay. This one. 1 L. I'm gonna spell everything, I guess. Selenium. No mono, just selenium. But then we do use the di for the 2 fluorines. It'll be difluoride. Like that. So selenium difluoride is SEF2. Very simple to name. Now, number 8. Trick question, but no, you cannot just write water. I will not count it correctly. You need to use the prefixes to tell what it actually is on number 8. Okay? Now, for the bottom part, quickly, the prefixes tell how many, right? So, like number 9, xenon hexafluoride, if there is not a prefix on the first one, just like we did with number 7, that means there's only one of them. So we have Xe for xenon, and then hexafluoride tells us hexa is 6, so we have 6 fluorines. So XeF6 is the correct formula for xenon hexafluoride. No crossing, no charges, no balancing. It just straightforward tells you what it is. For like 15 tetracarbon nitride. Tetracarbon means that there's 4 carbons, and then nana stands for 9, and nitride is nitrogen, so there's 9 N's. So C4 and 9 is that. Okay. So if you are all good and don't have any more questions right now, you don't have to stay on. You can go ahead and leave the Zoom call. If you do have more questions, we can continue to work on those. Like I kind of guessed this before, but the molecular compounds is a lot easier than the acid part. The acids, out of all of the different types of compounds, those are the most difficult. The first part on number 8, like the H2O right here. That would be, nope, dihydrogen. So since it comes first, you don't have to change it to IDE. You just keep it hydrogen. So dihydrogen. And then the O, there's only one of them, and it's second, so we do use the mon, but we say monoxide. So dihydrogen monoxide. I won't get it wrong if you put monoxide, but sometimes like you drop a vowel when you're putting it there. So that's how you do You're welcome. Okay. So again, if you are good to go for now, or if you want to stay on just in case you have more questions, you can. Otherwise, you can go ahead and leave the call. I'm going to stop recording, but then I can help out with the naming acid.